Hi there, my name is Will, and today I'm going to walk you through how you can migrate your Python code into Kestra so you can orchestrate your code. Now, before we jump in, let's take a step back a second. Why would you want to orchestrate your Python code? Now, there are a number of good reasons, such as being able to automate the process of running the code, being able to pass in parameters automatically, and just generally making it easier to connect your Python code to more services. I'm going to walk you through a few examples of where Kestra can help enable this practice and make it easy for you to use. Jumping into Kestra, I've got an example here of where we're running Python code. Now there are two ways you can run your Python code. You can either write it directly inside of your workflow like I've done here, or you can call an external file like you would on your local machine. For this example, I'm writing it inline and I'm using the Python script task. Now this allows me to install any dependencies before it runs and then write it directly inside of my workflow. This is really useful if you want to just write a short amount of Python code to manipulate some data, for example, and then be able to run later tasks. I'm going to execute this so we can see what it does and how it produces logs. And as we can see, it's going to run this, and it's going to run it inside of a Docker container by default to keep our dependencies isolated. And once it finishes, we can see that it produces an info level log with all of the data from our print statement. So we can easily see here what happened, and any errors that might come up will appear here too. So it makes it really interactive, and all of the code we wrote here is vanilla Python and could be run outside of Kestra. In our next example, we are running the Python code in its own .py file. And we're then able to call that using a command here, such as python main.py or any other command that you would use inside of your terminal. Now in this example specifically, we have a container image here, and this container image is set to use the PyData image that we store on GitHub. Now this includes a few extra packages, so this makes it nice and easy to be able to manage those dependencies without having to install all of them each time. All of our code is in a separate file, which is available in the namespace files section. Now we can import these files or create them directly inside of Kestra, or in an example I'll show you in a second, we can synchronize these or clone them directly from GitHub. Now my file looks a bit like this, just like the one where we wrote it inline, but this time it's going to run it from a separate file. This is often quite useful if you already have existing code that you want to continue to write locally and you don't want to have to continually copy and paste it into your workflow. So this is definitely much better for bigger projects. So let's execute this and see this in action. And as you can see here, I've got the same result as I got last time, but this time it was in its own dedicated py file. Let's have a look at a few more complex examples that used multiple tasks. I've got a few workflows here that are running Python. To start with, we have this inline one where you can write your Python code directly inside of your workflow. And these workflows are defined in YAML to make it human readable and easy to use. Now with this Python script task that we have here, I'm able to write my Python code directly inside of the YAML. But the other benefit is I'm able to pass in data dynamically straight to my code. So here I have a number of inputs that are going to allow me to pass information in when I run this workflow, and I can then add that value straight into the Python code with an expression. And so this makes it really easy to take your Python code and integrate it into Kestra dynamically. But let's say you're in a scenario where you don't want to do that because you've got dedicated files. You can also sync and clone them directly from a Git repository. So let's have a look at that. Here we've got the sync example here, which is going to sync our files to the namespace, which is the area inside of Kestra where files can be stored. So when I run this workflow, we'll then be able to run this file by simply running the command like we would on our local machine. And then we can pass in a bunch of variables as environment variables, just like you would if you were running it on your local machine. But the thing that makes this special is this will automatically get the code every time it's run from GitHub, so you can guarantee it's going to run the most up-to-date version. And it's got a trigger here at the bottom that is going to automatically run it too, so you don't have to even lift a finger. This is going to automatically run your code, and if something does go wrong, it can send us a Slack notification to let us know there was an error. Now, when I execute this, we'll get this really nice Gantt view that will help us visualize what's going on, and we can see that it has in fact cloned our files and it has successfully processed our code, and we've got the result here as a Slack message, which we can view too. And if I press edit here, we can see that we now have a namespace file which was inside of our Git repository. So this Orchestrator really allows you to build this seamless flow where your code can run itself, it can pull the most up-to-date changes, and you don't have to lift a finger. And the other thing is you can integrate it into other services. As you saw earlier, I was able to take the result that it produced and send it as a Slack message. So I was able to get the output, which was generated using the Kestra library, which you can see here, and I'm able to then pass data from my code back to Kestra. This event-driven workflow allows us to then be able to use data produced by our code in other services without having to write it all inside of our code. And as you can see at the bottom here, I also have an S3 task. So here I'm able to use S3 and upload the result of my Python code without having to implement that directly inside of my Python code. So it means I can focus on the bit I want to do in Python, which in this case is processing a CSV file, and allow Kestra's tasks to take off the effort, such as uploading a file to an external service or sending a Slack notification. We can do it again, but this time creating a working directory where we can clone the files inside of the workflow execution, and then it can then just access as if it's a file on the machine. So here I'm going to clone the Git repository using my GitHub repository, and then I'm able to just navigate to the folder and execute my Python code just like I would on my local machine. But the key thing here is the working directory is only going to run for that execution. So these files will not be stored for other flows to access. It's just for this one execution, which is quite useful if your files often change and you don't want them to be accessed by other workflows. Not only can you integrate your Python code around other tasks, you can also send a load of information from your Python code back to Kestra. Here's an example where using the Kestra Python library, we can create a logger object and then send logs directly to Kestra's logs. So here we've got different log levels such as info, warning, error, and critical, and when I execute this, we'll see that those log messages will get labeled appropriately with the correct level. So here we'll see here we've got warnings, we've got errors, and we've got info, and I can also see debug as well in here too. Now, while Kestra allows you to really integrate your Python code, you don't have to. If you simply want to keep your Python code completely vanilla, you can do that too. All you need to do is make sure that you can import it to Kestra or sync it using GitHub, and then you can then run it directly as a task. It doesn't need you to create a logger image. You don't need to use the Kestra Python library to send data back. If you simply want it to run and just run on a schedule, you can do that without having to modify your code. And as you can see here, I have a simple Python script here that says hello world, and this is able to run absolutely fine. And if I wanted to, I can even add a trigger here at the bottom to let me know, to be able to automate when this is executed. I can also set up event-driven triggers to tell this to run when certain events have run, maybe when a file's available. I can then also pass files to it without even having to modify the code. So I can create an environment just like I would on my local machine without having to modify the code, meaning that you can run anything you want Python-wise inside of Kestra without having to go through the hassle of making it work for Kestra. We have those libraries available so that if you want to extend it even further, you can, but they're not required to use Kestra. Here's an example that is able to use Kestra to download a file for us. We can pass this over to our Python code as an input file, as if the file was just in the same directory as the code. And then as you can see here in the Python code, I'm able just to read that just like it was on my local machine. There is nothing in here that is unique to Kestra. So when I execute this, it will be able to get the result from the CSV file just like it was on a local machine without having to do anything special that Kestra provides. I've now modified the Python code now so that it has an output file. As we can see here, it's going to read our CSV file and it's going to write a file with all of the headers from that CSV file. So now what we can do is going to our workflow, we can just specify the output files we're expecting, but we can also use regex here to be able to allow multiple files rather than listing them individually. And then I can access that file in a later task, such as here, where I'm able to then specify headers.txt and then print that out using an expression. So when I run this, we'll see that it's going to simply download that file, pass it to Python. Python's going to process that, and then it's able to then pass the data it produces as a file back to Kestra that we can then use in another task. But the key thing here is this Python code is entirely vanilla. There is nothing about this that is unique to Kestra, meaning integrating your Python code to Kestra is a breeze. So to summarize, there's loads you can do with your Python code in Kestra. With your code straight away, you can pass input files to your workflows and have your Python code interact with those. You can also have your Python code generate output files, which you can then access in Kestra and use in later tasks without having to modify your code. On top of that, you can set when your workflow runs, whether that's on a schedule or something event driven. This means that you can have your Python code run exactly when you want, but you again still don't have to modify your code. On top of that, you'll get standard logging where you'll be able to access the logs produced by Python already inside of Kestra. And this includes print statements as well. So you'll be able to view all of that easily in Kestra, especially when you maybe run into a problem, you'll be able to figure out what went wrong. And you can pass variables straight to your code using environment variables. So you can pass data that's generated by other tasks or input values and then package them up as an environment variable that you can then access in your code. This means you can then still run your code outside of Kestra, maybe for local development, without having to deal with any modifications that make it a bit more Kestra specific. But if you do want a few extra things, you can achieve that too. By using the script task rather than the commands task, you can write your Python code inline inside of your workflow, which now enables you to write Kestra expressions directly inside of the code. So if you want to pass data in rather than using an environment variable, you can do it with an expression, which is super useful for short scripts just trying to do a few things that you don't plan to reuse or run locally. On top of that, using the Kestra Python package, you can actually pass outputs back to Kestra. So if you generate a big JSON file, or maybe you generate a bunch of different variables that you want to be able to use in later tasks, whether that is to upload the result somewhere or send a notification, you can use this to package it up as a dictionary and send it back to Kestra for you to then use in a later task. Along with that, the Kestra package also allows you to do custom logging, where you can send custom log messages with specific levels so that you can see those in Kestra really easily. Maybe you want to set a warning when something doesn't work, or maybe fail your workflow and set a specific log so that you know why it failed. The custom logging in the package makes this nice and simple. And lastly, you can do timer and counter metrics inside of your Python code too. So if you want to time how long a function took or count how long something went on for, you can then send that data back to Kestra instead of as an output, this time as a metric to view under metrics, which makes it a little bit easier to be able to view what went wrong and compare it to different executions. So to summarize, there is loads you can do with Kestra, and the key takeaway here is that you can run your code straight away without any modifications. So if you're interested in giving it a go, I encourage you to download Kestra and have a go and see what you can do. But if you want to learn how you can extend it further, we've got a whole series of videos on how you can do this. So make sure to check those out in case you're curious. Hopefully you found this video useful and you're going to give Python a go inside of Kestra. Let us know what you'd like to see in the future from Kestra on how it supports Python, and if there's anything that you would love to see in a future video.